therein. Now, why he has given curved so that there should not be any impulse. Actually, in this diagram, what is the problem? When the block M1 comes here, no? So when it is landing onto M2 open, an impulse will act. To avoid that impulse, to minimize that impulse effect open, he has made a curved thing. So the same problem is available in book where he's telling the block will smoothly land onto the other wedge and don't consider any impulse effect. I'll cover both so that you'll not get confused here. Now I'll release it from a height h. Then as it slides down. So in what direction the M2? M2 should move towards left. M2 should move towards left. It'll start moving towards it. So finally, so what we'll get is, so when this is here, M2, this will have V2, no? Velocity, or VA will call it. This is A, this is B. This will have velocity V1. The other wedge will be there only. I'll have to show it being displaced. Yeah? The other wedge will not change its position, will be there only. Now it will land onto the ground and is a ground. Most of you might be knowing, I'm just picked up for to explain the center of mass concept. Now tell me what will happen to the how to calculate VA and V1. Decrease in potential energy, M1 GH should be equal to M1 V1 square plus M2 VA square. Applying conservation of momentum. Applying conservation of linear momentum. A component of velocity will be there in that direction. No? Because at this particular point, a component of velocity will come into picture. So here this is theta I'm taking. This will be theta. So here actually it will collide. Then due to collision what happen, you should not bother anything. So just what happen, it will retain speed and it's going to move down, or this vertical component will be reduced to 0. To avoid all this, he has made a problem like this. This will be much easier. The block will smoothly land onto the other incline without losing kinetic energy. So actually practically if you take it, this will be situation. So to overcome all that collision, so the problem what happened, according to the given problem, it will land onto the ground and it will have a speed V1. So we'll assume that the collision occurred and everything, it will land smoothly.
Sir,
yeah.
won't there be potential energy for M2? If we consider M2 as center of mass, then
wait. Let me finish off. Potential energy of the wedge A, what happened, where center of mass of the wedge A, there will be there only, no? Finish off. Simple idea. Where the center of mass of the wedge A is, there will be there only. Center of mass of wedge A will not shift, no? So therefore only decreasing potential in the block will convert into kinetic energy. Same problem, it's available in advanced question where it will come and strike, it collides inelastically. Later on collisions we'll discuss that. So it will land smoothly. Okay, with this solving V1, VA are unknown thing. Okay, I'll solve it, I'll get V1 and VA. Now what will happen? This was at rest, system was released from rest, no? Now what will happen to this M1? It will assume no collision, it will land onto smoothly. So the moment as it starts sliding up on it, I'll proceed. So this will continue to move. Now what is the situation for this? It's a very good problem. Just so nice, you can say basic concepts you can analyze here. And the block will be sliding up here. I'll take that diagram. Take this one. What is the state of the block? Block now it has landed onto the M1, onto the wedge. It will have some velocity, say V1 dash, and the wedge will have velocity, say VB dash. And this will continue to move at a constant speed. Tell me what happened to center of mass here? Anything will happen? The center of mass, what is the state of center of mass? Where the center of mass of system should be? Somewhere here. Tell me what happened to center of mass. It will not shift its position. It will not shift its position. It will be there only. But it will move, it will descend vertically down. So now where it will be? Now also the center of mass will be, it will not change its horizontal position. Only what happens, it will have vertical displacement. Clear this? Any reason for that? Net force acting on system along x-axis 0. So there won't be displacement of, and initial system is released from rest. Center of mass of at rest, and it will retain the inertia of rest. Along x-axis. Along y-axis, net force is non-zero, it will descend. Clear this? Okay, now let's analyze here. What will happen to the block? What are the forces that are acting? N1. Now, what makes the wedge to move? The normal contact. Here, M1g sine theta. Now, what do you expect the velocity speed of the block? Keeps on decreases, no? So, what will happen? A condition here. So, at one instant, the block will come to rest with respect to wedge. At one instant, the block will come to rest with respect to wedge here. And now this is, and both will have a common velocity. Both will have a common velocity. So show with respect to ground like this. And it has ascended some height. I'll call H max. This H max, will it be equal to H? Definitely no. Now how to apply conservation of momentum? You apply between this diagram. What is the conservation of momentum? M1 V1 should be equal to M1 plus M2 into V. Then again, M1 V1 square should be equal to M1 GH max plus M1 V square by 2 M2 V2 square by 2. The kinetic energy of this block here, the kinetic energy of this is what? Convert into kinetic energy of block plus wedge and the H1. So can you expect H max to be equal to H? That's what my question. H max equal to H? No, H max must be less than H, no? If H max equal to H, any problem? What will not be conserved? I think I can't again show only. Yeah. Is it H max equal to H? Can it go back to that initial height here? Can it reach till here? If it reaches till here, any problem? Look at this. The system is released from rest, no? It was having only gravitational potential in M1GH. Agree this? Then if the M1 reaches the top edge of the block of the wedge B, if it reaches here, what is the problem? What problem arises here? What is the state of this wedge A will be moving? The wedge, both the block and the wedge here will be moving. And here, what is the potential? M1GH. Then from where that additional kinetic energy came. So law of conservation of energy will be violated. So therefore, this M1 should not reach this particular point. So therefore, H max will be less than H only. After this, again, what will happen? So what conditions will arise? So this will continue to move. The block will be moving here with the velocity, and the wedge this will be the final thing. What happened? The velocity of center of mass. Finally, what will happen to center of mass? Center of mass, where it is, it will be there only. On the ground, it will be lying and it will be at rest. So what is the velocity of center of mass in the total course of the thing? It will be 0. It has descended only vertically. It never shifted along x-axis. Any theoretical good questions can also be asked for. You have to be careful. Okay, now, so let's, I'll give the same concept. Now with friction, I'm bringing that idea here. Yes. So it should be clear that VCMX. So I think I'll make it still more clear. The center of mass will never had velocity along x-axis. Along y-axis, it first what happened? Descended, then ascended, again descended. Able to understand? The center of mass first descended, then ascended, then again descended. So in the course of this everything sequence, center of mass what happened? Shifted along y-axis, and there's no displacement of center of mass along x-axis. Okay, now read this question. There's a friction I'm bringing because we avoided all the friction thing, no? So in this situation, I'm bringing the friction idea.